In this video, we are going to go over 3.3, increasing and decreasing functions, and how do we use first derivative test, and also line approximation and the motion. So first, how do you check if the function is increasing or decreasing? So we take the derivative. If the derivative is positive, it's increasing. If the derivative is negative, it's decreasing. If the derivative equals 0, in this case, f is constant on this interval. For example, 1. So given fx, first we take the derivative. 2x plus 3, we set this equals 0. We find the critical point. So now we draw a line. So negative 2 over 3. On the left, we are going to check the sign of the derivative. You can plug any number in. For example, you can plug in x equals negative 2. If you plug negative 2 in where? Into the derivative. So negative 2, you don't have to evaluate, just check this is negative. Here you can plug 0 in, so it's positive. So negative means it's decreasing. Positive means it's increasing. Same thing for 23, you need to use product rule to take the derivative, find the critical point, and do the sign analysis. Same thing for 25, product rule. Be careful when you do the product rule. And if you look at the critical point, here, when we take the derivative, there are two critical points. The numerator equals 0, give us x equals 1. And also there's a point x equals 0 where the derivative doesn't exist. This is also a critical point. However, x has to be greater than 0. So this, we're now going to consider x equals 0. So now let's have a look at this line here. So 1, that's only point, critical point. So from 0 to 1, f prime is negative, so it's decreasing. From 1 to infinity, the derivative is positive, so it's increasing. So how do we use the first derivative test? And how do we do the linearization? So when we do the sign analysis, if the derivative changes from negative to positive, so from decreasing to increasing, that will give us a relative minimum at this point. If the derivative changes from positive, so it's increasing to decreasing, this will give us a relative maximum. And if f prime is positive on both sides of C or negative on both sides, that means the sign of f prime doesn't change, then this point is neither a relative max or min. So these are the pictures for relative minimum. So decreasing, increasing, minimum. Increasing to decreasing, relative max. Because we are looking at the open interval, this case is the relative max and min. Sometimes this relative and max and min will be the same as the absolute max or min. So let's have a look at this example 27. So given this function, we take the derivative, set equal to 0. This is the only critical point. Now we are going to do the sign analysis here. So x equals 3, we draw a number line. So we are going to check f prime, the sign of the derivative. We plug it in number, so 0 or 4 on the right. So it's negative here, positive here. That means it's decreasing here and increasing there. So will be a relative minimum. So be careful how we word it. Fx will have a relative minimum of negative 4 at x equals 3. So 29, 31, when you take the derivative, you just need to be careful. Let's look at 31 together. So we need to use the quotient rule when we take the derivative. And this is the answer for the derivative. Keep in mind, x equals 0 is not defined. So x equals 0 is not a critical point. Okay? However, when we draw the number line, we do have to include 0 here. Be careful here because x cannot be 0. So we just put a point there. So negative 8 and 0, there are 3 intervals. 1, 2, 3. We check the sign of each. And increase, decreasing, increasing, decreasing here. So at fx equals, when x equals -8, the function will have a relative minimum at x equals -8. So 33, trig functions. First, we take the derivative, and the interval is from 0 to 2 pi. Now we take the derivative set equal to 0. We get tangent of x equals -1. So how do we solve these trig equations? There are two values of tangent. This is pi over 2. This is 3 pi over 2. This is 2 pi. So when tangent of x equals -1, there are two values here. And another way is, first, we can solve tangent of x equals +1. So this gives us x equals pi over 4. This will be our reference angle. Tangent equals negative. We have second quadrant and the fourth quadrant with reference angle pi over 4. So we can solve this easily. So this angle is 3 pi over 4. And this angle is 7 pi over 4. So after we get the critical points, we can just check the sign. So from negative decreasing to increasing give us a relative minimum, the y value at 3 pi over 4. From increasing to decreasing at 7 pi over 4, this will give us a relative max. We plug 7 pi over 4 into fx, give us y equals square root of 2. So next page will be the line approximation. So given any graph, fx, at any point, we can use a tangent line to approximate the value around this point. For example, given fx equals x squared, how do we approximate f point 1.9? So let's look at 1.9. The closest point will be x equals 2. So we are going to use the tangent line at x equals 2 to approximate the value at 1.9. So first, we take the derivative. We plug 2 in, so this will give us the slope. Next, we are going to use the point 2, 4. So use this point. This is the equation of the tangent line. And now we plug 1.9 in. This is our approximation. So let me show you a picture. What does this mean? Okay, so for example, this is 1.9 and this is 2. So we are trying to find the closest number to 1.9, which is 2. We use this tangent line. To approximate, this is approximation. This is L, and this is the real 1.9. Okay, so this one will be underestimate because it's concave up. Concavity, we are going to go over this next lesson. Same thing for 7 and 8. You can try it. So this one, we are trying to use x equals 2 to approximate. Same thing, x equals 2. Last topic, motion along a line. So in this exercise, we are going to find using derivative to find the velocity and the direction where the particle is moving. For example, given s of t, this is the position vector, a position function. So when we take the derivative, this will give us the velocity function. When we set the velocity equals 0, so velocity equals 0 is a very important point. Velocity equals 0, that means the particle is not moving at that point. So this equals, at t equals 3 over 4, the particle stopped moving. Now we look at the sign of s prime, or it's the same thing. We look at the sign of the velocity. If the velocity is positive, that means you are moving forward. And if the velocity is negative, that means you are going back. So if this is positive, that means from 0 to 3/4, it's moving in a positive direction. And 4/3, 3/4 to infinity, is moving in a negative direction. Okay, everybody finish the notes problems and also the homework questions. If you have any questions, let me know.